Good morning, sir. My name is NAN Sevmini and MF number 2023-8542. Today, our group is presenting a clear explanation and application of the paired samples t-test. The main aim of the presentation is to explain the concept in a simple way and show how it is used in financial econometric analysis. In this presentation, we examine how the paired sample t-test can be used to analyze changes over time using real financial data from companies in the insurance sector listed on the Colombo Stock Exchange. We focuses on 2 consecutive years, 2021 and 2022. The year 2021 represents the period before a major economic change, while 2022 represents the period after that change. The major economic event considered is the sharp increase in interest rates and treasury bill yields in 2022. The key variable we analyze is the investment income ratio, and our objective is to see whether this ratio changed after the interest rate hike. The paired sample t-test is used when we want to compare two related values from the same unit. The observations are naturally paired, meaning both values come from the same firm or entity. Unlike an independent sample t-test, the test focuses on changes within the same unit over time. In our study, the same insurance companies are observed in 2021 and 2022. So, each company provides a pair of related observations. This approach controls company-specific characteristics and helps us to clearly identify the effect of the interest rate change. The test checks whether the average change within the company is statistically different from zero. For the paired sample t-test to give reliable results, certain assumptions or conditions must be satisfied. The first one is the variable must be quantitative and continuous. Each value must have a matching observations across the 2 periods. The paired observations should be independent and the differences should be approximately normally distributed. The paired sample t-test is commonly used in before and after situations. Examples include comparing student performance before and after training, patient health indicators before and after treatment, the company performance before and after policy changes. In this study, it helped us to assess whether 2022 interest rate hike affected the investment income of insurance companies. To apply this test, we calculate difference between 2 values for each company. The difference shows how the investment income ratio changed from 2021 to 2022. If the average difference is close to zero, there is no real effect. If it is far from zero, it suggests that the interest rate change had an impact. The null hypothesis states that there is no change in the average investment income ratio after the investment rate hike. The alternative hypothesis states that the average investment income ratio changed after the interest rate hike.
My name is KK Hiruni Nivartana Amarasinghe and my MF is 2023-8524. Now I will explain our data source and sample. First, our sector is insurance companies listed on the Colombo Stock Exchange. Our data source is the annual reports for 2021 and 2022. These reports are audited and publicly available, so they are reliable. We use a sample of 10 companies. The companies are Union, Amana General, Selinco, Cooperative, LOLC, People's, Janashakti, HNB, Sanasa and Amana Life. Our main condition is that Each company must have annual reports for both years because we need data for 2021 and 2022 for the same company. Next, I explain how we collect the numbers from the reports. For each company and each year, we read two figures. From the income statement, we take investment income or net investment income. From the statement of financial position, we take total assets. Then we check the both numbers, use the same currency and units. For example, rupees in million. Then we use the investment income ratio defined earlier. Ratio is investment income divided by total assets multiplied by 100. We did this calculation for 2021 and 2022 for all 10 companies. This slide shows our main data table. Each row represents one insurance company. On the left side, under 2022, we have total assets in 2022, investment income in 2022, and the 2022 investment income ratio, which we calculated using two numbers. On the right side, under 2021, we show the same three items for 2021. So this table links the raw financial data from the annual reports with the ratios we will use in our t-test. Here you can see our workings table based on the ratios. The second column shows the 2021 ratios, which we call X, and the third column shows the 2022 ratios, which we call Y. In the next column, the square root of X minus X bar, we take each 2021 value minus the mean of 2021 and square it. In the next column, the square root of y minus y bar, we do the same for 2022 values. In the last column, x minus x bar multiply y minus y bar, we multiply the two deviations. At the bottom, we have the totals, and from those totals, we obtain the mean ratio for 2021 and the mean ratio for 2022, the standard deviation for each year, and the covariance between 2021 and 2022 ratios. These summary values will be used later to compute the standard error and t-test statistic. Finally, this slide explains why our data fit the paired samples t-test. We use the same 10 companies in both 2021 and 2022. The pairs from different companies are independent and the ratios are continuous data. Because of this structure, our sample is suitable for a paired samples t-test. Next, we move to the calculation part where we use these numbers to find test statistic and make decisions.
I am Nasibas Nayagar. My MF number is MF 2023-8597. In this calculation, there are 5 steps. First one is develop the hypothesis. Second one is determine significant level. Third one is calculate the test statistics. Fourth one is determine confidence interval, and fifth step is interpretation. So let's do calculation. In this calculation, first we should calculate these parts. We should calculate total sum of these values. So we selected 10 companies. In briefly, I will get the sum of these values. So our first step is develop the hypothesis. First one is in this hypothesis we should identify there are two hypotheses. First one is null hypothesis, second one is alternative hypothesis. So we should get these two type of hypotheses. Null hypothesis, it represents H0, and alternative hypothesis, it represents H1. There are let's see the what are these null hypotheses. Mu x minus mu y equals 0 and mu x minus mu y not equal to the 0. First one is first step is that one, and second step is determine significance level. We choose that significant level at the 5%. Next part is calculate the test statistics. Under the test statistics, first we should get the t value. How should we get t value? T value get x bar minus y bar. We should represent as the mean difference. Okay, I can write it, and divided by standard error. This is the first function you should identify. So let's write t equal x bar. So next step is calculate the x bar, mean of x. So we get as a mean of x here 20, 21, and y bar is mean of here 22. So I previously calculated it. So x bar is 6.347, 6.341, and y bar is 9.249. So we can apply it. 6.341 minus 9.249 divided by standard error. This one we should calculate. Next, second part is our calculation is calculate the standard deviation. What is the equation of the standard deviation? Standard deviation equals sum of square divided by degree of freedom and square root. This is the our second function. How to calculate sum of square? Sum of square equals sigma x minus x bar square. This is the another calculation we use. How to calculate degree of freedom? Degree of freedom equals n minus 1. These are the major formulas we need. So let's do this calculation one by one. Next we calculate standard deviation of x and standard deviation of y. Let's calculate the standard deviation of x equals sum of square of x divided by degree of freedom x. Sum of square of x is this one, sigma x minus x bar to the power 26.112 divided by this selected as 10 company. So degree is n minus degree of freedom is representing n minus 1. So number of companies are 10 minus 1. 10 minus 1 equals 26.112 divided by 10 minus 1 equals 9. So 2.901 is square root. So 1.703. Next we calculate standard deviation of y. Sum of square y, y minus y bar to the power 64.282 divided by the degree of freedom y 10 minus 1. 64.282 divided by 10 minus 1 9. 7.142 to the square root. Answer is 2.672. So we calculated standard deviation of x and standard deviation of y. Next step is calculate variance of these x and y. So next step is calculate the variance. Let's see how to calculate variance. Standard deviation, variance is x to the power sum of square x divided by degree of freedom. Sum of square is x is sigma x minus x bar to the power. So 26.112 divided by degree of freedom 10 minus 1. Variance of y, sum of square of y divided by degree of freedom 64.282 divided by 10 minus 1. First we calculate the variance of x. 26.112 divided by 10 minus 1 9 is 2.901. Variance of y 64.282 divided by 10 minus 1 9. 7.142. This is the variance. So next part is calculate the coefficient of correlation. What is that function of the coefficients of correlation? Let's see. X and y equals sum of x minus x bar to the y minus y bar divided by square root of sigma x minus x bar to the power multiplied by, don't write it, sigma y minus y bar to the power. This is the formula of coefficient of correlation. So let's see these elements in one by one. First one, we need sigma x minus x bar to the y minus y bar of sigma. I previously calculated this 13.964. I calculated this r and y 30.964. 964 divided by sigma x minus x bar power multiplied by y minus y bar to the power. This is the value 26.112 multiplied by 64.282 and square root it. So let's do the calculation. 26.112 multiplied by 64.282 and square root the answer 30.964 divided by 4.096 divided by that answer. The R value is 0.755 blah blah blah. So we get final answer of R is 0.755. Next step is calculate the standard deviation of difference. Let's see what is the formula of standard deviation of difference. SB equals variations of x into plus variance of y minus 2r multiplied by standard deviation of x multiplied by standard deviation of y to the square root. This is the function. So we apply this apply data to this function. First we need to variance of x. First one is 2.901 plus variations of y 7.142 minus 2 into the r value. So we calculate r value as 0.755 multiplied by 0.755 multiplied by standard deviation of x and standard deviation of y. Standard deviation of x we calculated 1.703 multiplied by standard deviation of y is value 2.672 and get square root of this value. Plus 7.142. This value is 10.043 minus, let's get the whole answer, 2 into 0.755 that will multiplied by 1.703 multiplied by 2.672 6.871 into the square root. So in my 10.073 minus 6.871 and square root of that answer 1.781. So we get the answer of standard deviation of difference. Next step is standard error of the difference. So how we calculated it? Standard error of difference. Standard of error of difference we calculated as the standard deviation divided by square root of n. This is the function. Okay. So we calculated standard deviation at the as a 1.781 and n. N is the number of companies we selected. Square root of 10. First we calculate square root of 10. 3.162. So 1.781 divided by that answer. So standard error of difference we get 0.563. So now we can calculate the answer of T. The standard error of difference is this value 0.563 and this value divided by 5.63. We can get the answer 6.310 divided by 9.429 and that answer divided by 0.563. The answer is minus 5.165. This is the T value of our calculation. So next step is the calculate the critical T value. First we should write it. Calculate the critical T. So we need a bell-shaped graph. So it like this. Middle point 0. So our T value is minus 5.163. Is represented like this 5.165. Next we should using the statistics table we should calculate the critical T. Using the vertical axis you should find the degree of freedom 9 and we should get the critical T value minus 2.262. So this is the rejection region. So our variable is in the minus 5.162 to minus 2.62 if we can reject our null hypothesis.
My name is HB Hansani Nimeshika Hansamali, MF 2023 8516. In my part, I like to dive into the confidence interval and the p-value to check our result. This graph shows the sampling distribution of the mean differences. The blue shaded area is the 95% confidence interval for mean of 2021 deduct mean of 2022. Our sample mean differences is minus 2.908. The standard error is 0.563. And with 9 degrees of freedom, the T value for 95% confidence is 2.262. So the 95% confidence interval is minus 2.908 plus or deduct 2.262 into 0.563 equal minus 4.18 minus 1.63. The red vertical line shows 0. The value under the null hypothesis. We can see that 0 is outside the shaded interval.
Now we can use this interval to make a decision. Our 95% confidence interval is minus 4.18 and minus 1.63. The whole interval is below 0. So mean of 2021 deduct mean of 2022 is lower than 0. This means the average investment income ratio in 2022 is higher than in 2021. Also, 0 is not inside the interval. So at the 5% level, the value no difference is not reasonable. Therefore, using the confidence interval method, we reject the null hypothesis and say that the rate hike is linked with a significant change. Actually, an increase in the investment income ratio. Um, this graph shows the t distribution with 9 degrees of freedom. The black curve is the distribution under the null hypothesis. The red dashed line on the left is our observed t statics about minus 5.165. Then the two red shaded areas at the tails represent the p-value for a two-tail test. The total p-value is about 0.00059, which is written in the box on the graph, and our significance level is 0.05. Because of 0.00059 is much smaller than 0.05, we again reject the null hypothesis. So both the confidence interval and the p-value method give the same conclusion as the critical value method. The investment income ratio of insurance companies in 2022 is significantly higher than in 2021 after the investment rate hike.
My name is Vijay Surya and my MF number is MF8610. In this part, I will explain the Fiat sample t-test using SPSS based on our investment income ratio data. First, we start with our data set in Excel. Here we have the investment income ratios for 2021 and the 2022 side by side. Each row represents one insurance company. Next, I open the SPSS software. I go to the variable view tab to set up our data. I define the first variable as ratio underscore 2021 and the second variable as ratio underscore 2022. I set the measure type to scale and I reduce the decimal to 2. This make sure SPSS read our ratios correctly as numerical data. Now I switch to data view. I copy the calculated ratios from the Excel sheet and paste them into SPSS. So now we have 10 match pair of data, one pair for each insurance company, before and after the interest rate hike. To run the fair sample t-test, I go to analyze, then compare mean, and I select fair sample t-test. I select ratio 2021 as variable 1 and ratio 2022 as variable 2. Then I move them into fair variable box. I clicked option to check the setting. The confidence interval is set to 95%, which match our 5% level of significance. I click continue and then OK to run the test. Now we can see the output in the first table, Fiat sample statistic. The mean investment income ratio in 2021 is about 6.34, and the mean ratio in 2022 is about 9.25. So on average, the investment income ratio is clearly higher in 2022. Next, we look at the Fiat sample correlation table. The table shows the relationship between ratios in 2021 and 2022. The correlation is positive and fairly strong. The support of our decision to use the Fiat sample t-test because the same companies are observed in both years. Now we move to the most important table, which is the paired sample test table. SPSS calculate the difference as ratio 2021 minus ratio 2022. The mean difference is negative, which tell us the ratio in 2022 is higher than in 2021. Now we focus on the SIG2 tail column. SPSS report this value as less than 0.001. The fee value is very small and clearly smaller than our 5% significance level, which is 0.05. Therefore, we reject the null hypothesis. We conclude that the increase in the investment income ratio from 2021 to 2022 is statistically significant. Finally, SPSS also report effect sizes. Quant D value is large, which show the increase is not only statistically significant but also practically meaningful. So the SPSS result confirm our manual calculation. Next, I will move to Minitab to explain the same result using graphical method, including confidence interval, critical t-value, and phi value decision. Now I use Minitab to show the same result with graphs. C1 is ratio underscore 2021 and C2 is ratio underscore 2022. The two columns from Excel and paste them here into Minitab worksheet. The fair t-test to confirm the same result we got in SPSS. I go to stat, basic statistic, and select fair t. I choose ratio 2021 as sample 1 and ratio 2022 as sample 2. Before running the test, I click option. Here I make sure the confidence level is set to 95%, which matches our 5% level of significance. Then I click OK to close the option window. Next, I click graphs. In this window, I tick individual value plot of differences. This option allow Minitab to draw the confidence interval graph for the mean difference. Then I click OK and again OK to run the fair t-test. Now Minitab show the output in the session window. We can see the same result as SPSS. The critical value is about minus 5.17 with 9 degree of freedom. The phi value is very small, less than 0.001. Minitab also report the 95% confidence interval for the mean difference, which goes to about minus 4.18 to minus 1.63. The confidence interval graph is generated automatically. We can see that the entire confident interval is below 0, so 0 is not included. Therefore the Minitab fair t-test confirm the SPSS result. That the investment income ratio increased significantly from 2021 to 2022. Next, I explain the critical t value decision using a graph. To generate the graph, I go to graph, probability distribution plot. I select view probability and click OK. Then I choose the t distribution and set the degree of freedom to 9. Under shaded area, I select both tailed. In the x value box, I enter 2.262. I click OK to generate the graph. Next, I edit the graph to add our test statistic. I right click on the graph and choose add reference line. In the x value box, I type minus 5.165. This represents our calculated t value from SPSS and Minitab. Now we compare the two values. The critical value are plus and minus 2.262, but our test statistic minus 5.165 lies far outside this range. So because the test statistic fall in the rejection region, by the critical t value method, we reject the null hypothesis. Finally, I explain the p-value decision using another graph. Again, I go to graph, probability distribution plot. I select view probability and click OK. I choose the tree distribution and set the degree of freedom to 9. Under shaded area, I again select both tails. This time, instead of x value, I enter the probability as 0.00059. I click OK to generate the graph. Now I edit the graph to add the significance level. I right click the graph and I choose add reference line. In the x value box, I type minus 2.262 and again plus 2.262. These line represent the 5% significance level, which is alpha equals 0.05. Now we compare the shaded phi value area with the significance level. The shaded red area representing the phi value is very small and it lies outside the critical line. Since the p value 0.00059 is much smaller than 0.05, by the p value decision rule, we again reject the null hypothesis. This confirmed that the investment income ratio in 2022 is significantly higher than in 2021. In all methods, the null hypothesis was rejected. Therefore, we conclude that the increase in investment income ratio after the interest rate hike is statistically significant for the selected insurance companies. Thank you.